Page 215. Number 4, we've got y equals x e to the 1 over x. We're supposed to find the critical points, right? So we have to use the derivative. We have to take the derivative, but there's a problem here. What's the problem? Oh yeah, there's that problem. We just have to use a product rule, and we'll also use, what other rule? We'll also use the chain rule. So dy dx equals, so I have, we have got two functions, right? One on the left and one on the right. We've got x and e to the 1 over x. So the derivative of x is 1 times, so it's the first derivative of the first function times the second. So that's L prime, I'll write that in a different color in a second, plus x times the derivative of e to the 1 over x, which is e to the 1 over x times, by the chain rule, the derivative of 1 over x. So what's the derivative of 1 over x?
Negative 1 over x squared.
Negative 1 over x squared. What's the integral of 1 over x? Natural log of x, right? So now also we have integrals. Please don't go the wrong way, now that you know how to go both ways. That can be a problem sometimes. Sometimes we get so excited about saying 1 over x. You're like, natural log, but not after taking the derivative. Okay, so we set this equal to 0. Oh yeah, so this was L prime r plus L r prime. Right, there's a product rule. Okay, so we set the derivative equal to 0. I'm going to go ahead and factor an e to the 1 over x out. I think that'll be easier. Right, Matt? So if I factor e to the 1 over x, it'll be times 1 minus 1 over x. Right? So I've got two things multiplied together that give me 0. So this means that either 0 equals e to the 1 over x or 0 equals 1 minus 1 over x. What can I plug into x to give me an exponent that'll take e to 0? Anything? What raised to a power gives you 0? Can you raise any number to a power to get 0? Ever? No. So it doesn't look like this is going to help us. It won't give us any critical points. Obviously, as I take the limit, as x goes to infinity, this function will approach 0. Right? So basically, as x gets really, really, really big, my function will get really, really close to 0, but it's still not a critical point. Right? That's just a limit by Cauchy-Bruce laws. Over here, though, we can say that 1 over x equals 1, so that 1 equals x. So 1 equals x should be a critical point. All right, so is the critical point. And now we have to figure out if it's a what? A max or min. All right, there's two ways. One way is to take the second derivative, plug in 1, and see if it's positive or negative. But this looks like really annoying to take the derivative of. So let's see if we can do it a different way. The other way is I've got this function, and we know that at the point 1, my derivative is 0. Let's plug in the point to the left of 1 in my derivative function. Like, I don't want to plug in 0 because that'd be bad. We'll plug in like a half. Alright, if I plug in like at x equals 1/2, dy dx would equal e squared times 1 minus 1/2. What do I notice about this number?
Positive.
It's positive. So that means to the left of 1 should be positive. The derivative is positive.
Wait, it should be 1 minus 2.
Oh, whoops. Oh, then the opposite is true. Yeah, plug in 1/2 and that's in the denominator. Good call. Good work. 1 minus 2 is less than 0, which makes this negative. Awesome. Okay. And then if I plug in 2, then we get, at x equals 2, we get dy dx equals e to the 1/2, 1 minus 1/2 now. And that is positive, right? So the picture is, when we have critical points, we've got two cases. And this is the case in which I've got a negative derivative into a positive derivative. right? So that means, what I'm saying is my tangent lines have negative slopes at a critical point, then my tangent lines have positive slopes, so we're right there.
Okay.
So that's going to be a minimum. And I think this way is a little bit faster than taking the second derivative and plugging in at 1. Sounds good?